today's video, we are going to be solving mathematics, and if you are writing any concours such as FET, COT, EGEM, ENS, ENSET, FASA, IUT, Public Works, SUPTIC, then this video is going to be very helpful to you. Now, question 1 says, given that x divided by 3 minus x multiplied by 4 minus x is equivalent to p divided by 3 minus x plus q divided by 4 minus x. Now, in this case, we know this is partial fraction, and we know for partial fraction there are two ways we can go about it. The first way is either we break down the first fraction into two fractions and equate the denominators, or we simply break down the two fractions into a single fraction and equate the corresponding numerators and the denominators. So we're going to go by the second method. Here we'll look for our LCM. So here the LCM will simply be 3 minus x divided by 4 minus x. So here, if we take the denominator, divide by all of that, we see 3 minus x will go away. So here we'll be left with b into 4 minus x plus q into if we do the same thing, we're going to be left with 3 minus x here. So now if we want to compare this with the initial fraction that was given to us divided by 3 minus x, then we see that the denominators are equal. So if the denominators are equal and this fraction is equivalent to this one, then the numerators should also be equal. So that is why we're going to have p into 4 minus x plus q into 3 minus x equal to x. So from here, there are also two methods that we can go about it. It's either we expand these two fractions and we equate corresponding coefficients, or we simply start letting the values of x to be some certain constants that can easily cancel out. So we're going to go by the second method. So if we let x to be equal to 5, we see that to be equal to 4, we see that p will easily be eliminated. So if we put 4 here, we are going to get 0. So this will be q into, if we put 4 here, we are going to get 3 minus 4, which will be minus 1, and this will be equal to, we know x is 4. So from here we can easily conclude that our q is minus 4. So our q is minus 4. Now if we do the same thing for for p, so if we let our x in this case to be 3, then we see that q will be eliminated. So we are going to put 3 there. So if we put 3 here, we are going to get 4 minus 3, which will give us 1. So we have p to be equal to 3. So now we see clearly that our value for p is 3 and our value for q is minus 4. So if we want to check the corresponding answers, we are going to get our answer will be C. So this is the correct option for this question 1. Now, question 2 says that when the polynomial p of x, where p of x is ax cubed plus 5x squared plus 2x, is divided by x minus 1, then the remainder is 4. The value for the constant a is, we know here we are using the idea for the factor and remainder theorem. Now for the remainder theorem, if we said if for the factor theorem, if x minus 1 is a factor of a polynomial, let's say p of x, then it leaves no remainder. In this case, p of 1 will simply give us 0. Now for the remainder theorem, if x minus 1 is not a factor and it leaves a remainder, let's say r, let's say the remainder is r, in this case p of 1 here would be equal to r. And to get our 1, we simply equate the factor, or we simply equate this to 0. So if we equate this x minus 1 equal to 0, then we're going to get x equal to 1. This from here, we now look for p of 1. So basically that's how you get p of 1. So if it was 2 here, it will be p of 2. If it was x plus 1, then we're going to get p of minus 1. Okay, now let's just solve equation. Okay, the question says that x minus 1 leaves a remainder of 4. So in this case, we're going to equate our x minus 1 equal to 0. So this will give us x to be equal to 1. So we'll be looking for p of 1 equal to 4. Now, p of 1 equal to 4. So we simply go back to our polynomial. We know our polynomial is a. This is our polynomial here. So we're going to substitute anywhere we see x, we're going to replace it with 1. So we're going to have a into 1 cube plus 5 into 1 squared plus 2 into 1. So this will give us 4. So in this case, we simplify. We are going to have a here plus 5 plus 2 to be equal to 4. So simplifying that, we're going to get 3 minus 3 minus 3. So the correct option here will be C. So the correct option here is C. Question 3 says that the range of values of x for which x minus 3 divided by x plus 2 is less than or equal to 0. So in this case, we're going to first of all look for the domain of this function. The domain simply is a range in which the function exists. So in this case, the denominator should be different from 0, because if the denominator is 0, then this function will not exist. So in this case, we are saying that the function x minus 3 divided by x plus 2 is real or exists for all values of r except at minus 2. So the domain of this function will be the set of r minus 2. Now, looking for the range, here we're going to look for our principal values or critical values. We'll look for our critical values, and to get the critical values, we simply equate the numerator and the denominator to 0. So if we do that, we're going to get x to be equal to 3, and if we do the same thing for the denominator, we're going to get x to be equal to minus 2. Now, these are our critical values. If we go now to our number line, we see that we'll have this our number line. We're going to put our critical values in increasing order. So the first value will be minus 2, and the second value will be 3. Minus 2 is less than 3, that is why minus 2 comes first. And between minus 2 and 3, there are range of values. There are some range of values that we're going to test also above here and below here. Now, we want all the values for which when we input it in our function, it should be less than or equal to 0. So we're going to test our values. You see that between minus 2 and 3, we can find 0. So 0 is found between minus 2 and 3. So we can test a value like 0 here. We can test a value like 4 here, and we can test a value like minus 3 here. So if we start with 0, then if we put our 0, if we substitute a value, this 0 in this our function, then we are going to have 0 minus 3, which will give us minus 3 divided by 0 there will give us 2. So we see that within this range, our value will always be negative. The value will always be negative within this range. Our value for this function will always be negative. Now let's try a value like 4. If we try 4, we see that if we put 4 in this function, we're going to have 4 minus 4 here, 4 minus 1 minus 3, which will give us 1, and 4 down here will be positive. So above here, all the values will be positive, and the same thing will happen down here. So all the values will be positive. Because let's take, for example, a number like -3 and verify. So if we put -3 in this function, we're going to get -3 minus 3 will give us -6, divided by -3 plus 2 will give us -1. So -6 divided by -1 will give us positive 6. So we see clearly that within this our range, the range of the critical values that were given to us, we see that here we have negative and here we have positive. But we're looking for the range of values for which this function is negative or less than. So the best option to choose there will be simply this. So the range will be this range. This is the range here. But now our domain said that it should be different from -2. So the range will simply be x should be less than or equal to 3, but strictly greater than -2. So we see that if you never took your domain at the beginning, then you obviously choose an options like option D, which is wrong. But if you look for your domain and you saw that this function not exists at -2, then you avoid that mistake. So the correct answer there is B, option B. Now question 4 says that the value of a half, this is logarithm. So we are simply going to simplify this. Simplifying this function using our basic laws of logarithm, we see that this is a half. The log of root 8 can also be written as 8 to the power a half, and base 2 here. So also this a half can be brought down here according to laws of logarithm. The law states that if we have log of a to the power n base b, then this can be written as n log of a base b. So we are going to apply it here. So applying that, we are going to have a half times a half log of 8 base 2. Now 8 can also be written as 2 times 2 times 2. So this will be 1/4 log of 2 to the power 3 base 2. So from another law which says that if we have log of a base b, then and a is equal to b and a is equal to b, then we are going to have log a base a, or log b base b, or log b base b. This will simply be equivalent to or equal to 1. So looking at this, we see log 2 base 2. So this will be equal to 1, and the 3 will come down here from the first law that we just stated, from this first law that we stated up here. So this will be 3/4. Now this one, log 2 base 2 will give us 1. So 3/4 times 4 will give us times 1. 3/4 times 1 will simply give us 3/4. So our option, the correct option there is D. Question 5 says that when 3 minus 2x, all that raised to the power a half, is expanded in ascending power of x, the range of values of x for which the expansion is valid is. So here we're looking at the range of values of x. Now we have to express this our function here, in the form let's say 1 plus ax, all that raised to the power n. Now for this to be valid, then the absolute value of ax should be less than 1. So expressing this, we have 3 minus 2x, all that raised to the power a half. So if we want 1 here, we're going to factor out 3. Factoring out 3, we are going to have 1 now plus, this can be written as plus of 2 now divided by 3x. Now this will be to the power a half. This will be to the power a half. And we see clearly here that we have already expressed in this form. Now we want the absolute value of this function. We want the absolute value of minus 2 on 3x to be strictly less than 1. So in this case, we'll apply our basic rule of absolute value inequality. So this can also be written as minus 1 is greater than the absolute value of minus 2x all over 3 divided by 1. So the absolute value of any function is always positive. So this will be minus 1 to be less than 2x all over 3 and less than 1. So multiplying all through by 3, we are going to get minus 3 to be less than 2x less than 3. Here the absolute value sign or the inequality sign didn't change because 3 is a positive value, so it will not affect. So if in a different question we are multiplying by a negative, then these these inequality signs will solely change. So we are going to divide all through by 2. If we divide all through by 2, we are going to get minus 3 on 2 should be less than x less than 3 on 2. The same thing will happen here if we were dividing by a negative number. The absolute value sign, the inequality sign, will change. But since 2 is a positive number, it will stay like this. So that's our correct answer. And if we look at the options, we see that the best answer there will be B. The best answer there is B. It looks like A and B, they're having the same so the best answer there, let's just say, is B. Okay, now question 6 says that the sum of the first nth terms of the sequence is given by Sn equals to 3n squared plus n. An expression of the nth term of the sequence is, so this is sequences and series. So we know that Sn has been given to us to be 3n squared plus n. And to get the nth term, let's say this is the nth term, Tn. The formula says this will be Sn minus 1 minus Sn. So it will be Sn minus 1. So I think let's say if we are given our Sn, this is our Sn. Sn is 3n squared plus n. And we want to look for our Tn. The formula says Tn is Sn minus Sn minus 1. So here we'll have to look for our Sn minus 1. So Sn minus 1 simply means anywhere we see n in Sn, we replace it with Sn minus 1. So it will be Sn minus 1 all that squared plus n. So if we simplify this, we are going to get 3 into, this is the same as n squared minus 2n plus 1 now plus n. So if we continue with our simplification, we are going to get 3n squared minus 6n plus 3 plus n. So if we further simplify, we are going to get 3n squared. Now minus 6n plus n will give us minus 5n plus 3. So if we substitute this back to this formula, we are going to have, and substitute this also here, then we are going to have Tn to be equals to Sn. Our Sn is 3n squared plus n. Now minus bracket open, we have our Sn minus 1 to be 3n squared minus 5n plus 3. So if we continue with our simplification, we are going to get 3n squared minus 3n squared result will give us 0. So it is something like this: 3n squared plus n minus 3n squared plus 5n minus 3. Here I'm opening my bracket. So when I finish opening the bracket, we're going to get Tn now should be equal to 3n squared will cancel with 3n squared. We have n plus 5n will give us 6n. 6n minus 3. So from here we can factor out 3. So if we factor out 3, we're going to get Tn will give us 3 into, here we're going to have 2n minus 1. 2n minus 1. So this is our correct answer. This is the correct answer. This is the correct answer. This is our correct answer. So the option is not there, so definitely option E. Let's say option E. Option E was supposed to be 3 into 2n minus 1. So if we go to the next question, question 7, which says that the sum of all of that, the sum from r equal to 1 to infinity of 15 into 1 on 4 to the power r is. So from here we see this is clearly sum to infinity, because we are summing this up to the infinity, and we know sum, the formula for sum to infinity is given as a divided by 1 minus r. A divided by 1 minus r. So we are going to look for our a, which is the first term, and our r, which is the common ratio. And to get the common ratio, we need at least 3 terms, and then we compare their ratios. So for r equal to 1, then we are going to get 15 divided by 4. Because if we put 1 here, we are going to have 15 divided by 4. Now for r equal to 2, then we are going to get 15 divided by 16. 15 divided by 16. For r now equal to 3, we are going to get 15 divided by 36. Divided by 36, because 4 raised to the power 3 is 64. So we are going to get 64 here. So here we are going to get 64 actually. For r equal to 3, this will implies we are going to get 15 divided by 4 raised to the power 3 is 64. Now from here we see that our a is 15 on 4, and our common ratio, we don't yet know that. Now to get a common ratio, we are simply going to look for r2 divided by r1, and then check if it's equivalent to r3 divided by r2. So looking at this, our r2 is 15 on 16, so this will be 15 divided by 16. Now divided by r1 is actually our r2 is 15 on 16, and now this will be divided by r1. R1 is 15 divided by 4. Since we are dividing, it will be the same as 4 divided by 15. So we see here that 15 will simply cancel with 15. 4 will go here 1, and 4 will go there 4. So this will be equivalent to 1 on 4. This will be equivalent to 1 on 4. Now doing the same thing for r3 and r2, where we add 3 divided by r2. Our r3 is 15 divided by 64, and our r2 is 15 divided by 16, which is the same as 16 divided by 15, because we are multiplying. So this will cancel, 15 will cancel, 16 can go here 1, 16 can go to 64 4 times. So this will be equal to 1 on 4. 1 on 4. So since this is equal to this, then our common ratio R will be 1/4. Now substituting this back in our formula for sum to infinity, we are going to get sum to infinity to be equal to A, which is 15/4, divided by 1 minus R. Our R is 1/4. So this will simply give us 15 divided by 4. Now divided by 1 minus 1/4 is 3/4. So simplifying this, we are going to get 15 divided by 4 now times 4 divided by 3. You see that 4 is going to cancel, and 3 will go here 1, 3 will go there 5. So this will be equal to 5. That's our answer. So the correct option there was option A. Question 8 says that the general solution of the equation sec theta plus 30 degrees is equal to 2 is. So we have sec theta plus 30 degrees to be equal to 2. We know that sec theta is the same as 1 on cos theta. So we are going to apply it here. So here we are still going to have 1 divided by cos of theta plus 30 degrees. So this will be equal to 2. So the 2 is the same as 2 on 1. So if you cross multiply here, we are going to get cos. So we are going to get cos theta plus 30 degrees to be equal to a half. So we're going to look now for theta plus 30 degrees to be equal to, we'll look for the cos inverse of a half, and we're going to get 60. Cos inverse of a half is 60 degrees. So you have to take note here. The reason being that when here we're going to have our principal value. Our principal value here is 60. Take note, the principal value here is 60, not 30. We're going to consider this as a single value. So we are not going to send 30 degrees this way. So since we're dealing with cos, the general solution for cos theta is theta n to be equals to 2 pi n plus or minus PV. The PV here is the principal value, and our principal value here is 60. So our theta n will consider all of this to be theta n. Never simplify. So it will have theta now plus 30 degrees to be equals to, we have 2 pi n plus or minus, the PV was 30 degrees. Now 2 pi is 360. So simplifying that down, we're going to have now our theta, the value for theta now to be 360 n, now plus or minus, our principal value is 60. So sorry, the principal value here is 60. Is 60, not 30. Is 60. So it will be plus or minus 60 degrees minus 30. So nothing will actually change. So theta will give us 360 n. Now if we consider the positive part of it, we have 60 degrees minus 30. We're going to have 30, and if we consider the negative part and the positive part here, we're going to get minus 60 minus 30, which will give us minus so basically the general solution will just be plus or minus 60 degrees minus 30 degrees. So basically theta n. So if we check our options, we see that the correct option there will be option C. So the correct answer here is option C. Question 9 says that sine 4 theta plus sine 2 theta divided by cos 4 theta plus cos 2 theta is equal to. So here, trigonometry, we know that to simplify this, we from the formula sine A plus sine B equal to 2 sine A plus B divided by 2 plus divided by 2 times multiplication times cos A minus B divided by 2. So the same thing will be done for cos A plus B. So cos A plus B, the formula states that plus cos B will simply be equal to 2 cos A plus B divided by 2 cos A minus B divided by 2. So we're going to apply these two formulas here to simplify this. So the common mistake many students might start doing is simplifying this using double angles identity, but if you do it, you will never arrive at your answer, or it will take you a very long time to do that. That's why we have to apply this formula. So if we do that, if we simplify it using our values given to us, we're going to get this. The numerator will be the numerator sine. The numerator will simply be 2. So I'm considering now the numerator here. The numerator will be 2 sine 4 theta plus 2 theta will be 6 theta divided by 2, give us 3 theta. Now cos 4 theta minus 2 theta will give us 2 theta divided by 2 will give us theta. And now this will be divided by cos 4 theta. Will apply the same formula for cos 4 theta, so it will be cos 2 cos 4 theta plus 2 theta will give us 6 theta divided by 2 will give us 3 theta. Now cos, we apply for cos y here now. So if we apply, we have cos 4 theta minus 2 theta will give us 2 theta divided by 2 will give us theta, cos theta. So we see that cos theta is common here, and also these two will go away with. So we'll be left with sine 3 theta divided by cos 3 theta So this will give us tan 3 theta. So that is the answer. Now let me note something. If the question gave us sine 2 theta plus sine 4 theta in the numerator, you are very free to swap the position before applying this formula, because A plus B is the same as B plus A, so nothing will actually change. So our correct option there is option A. The last question, question 10. The sine of the acute angle between the plane pi and the line L, where pi is x minus y plus z equal to 0 and L is that, then the acute angle, we know that the sine of the acute angle, we are looking for sine. The formula says that sine of the acute angle, let's say the angle is theta in this case, will simply be the dot product of the normal vector with the direction vector divided by the dot product of the norms of the normal and the direction vector. So we're going to look for the norm of the direction vector and the norm of the normal vector of the plane. Now to get the normal of the plane, we see that for a plane is represented as r dot n equals to d, where d or any constant c, where c where r here is the coefficient x, y, and z, and n is a normal. So this our plane can be represented as x, y, z dot of 1 minus 1 1. So how did I get 1 minus 1 1? This 1 minus 1 1 are simply the coefficients of this, the coefficient of this. So the coefficient of x is 1. So where I have x, I'm going to put 1, and the coefficient of y is minus 1. So this will be equal to 2. So if I expand this, I'm going to have this. So our normal vector here, the normal vector will simply be 1 minus 1 1. We're finished with the plane. Now for the line, to get the normal vector, we know for a line is stated as r. The general formula is r equals to a plus t times d, where d here is the direction vector, t is a parameter, let's say t. From here we can easily get it. The d, the direction vector, will simply be the denominator, the coefficient, the denominators of each of these terms. So it will be 2 2 and 1. That will be the direction vector. But now the most appropriate way to get it is we equate all of these to a parameter, let's say t. If we equate this to a parameter t, we are going to have t to be equal to x minus 2 divided by 2, and also t to be equal to y plus 1 divided by 2, and t to be equal to z divided by 1. Since all of these expressions are equal, then they should also be equal to this parameter. So here, this one will imply that I'm going to get 2t to be equal to x minus 2. And here it will imply that I'll have 2t to be equal to y plus 1. And here it implies that t to be equals to z. So if we make our x, y, and z subject here, we're going to get let me change the ink. We're going to get 2t plus 2 to give us x, and here we're going to get 2t minus 1 to be equals to y, and here we're going to get t to be equal to z. So expressing this in this form, here our r, these general equations can be written as x, y, z to be equal to x naught, y naught, z naught plus t into another value, let's say a, b, and c, which is the direction vector in this case. So if we do that, we're going to, let me create some space. So if we do that, we're going to have x is so x, y, and z will be equal to, here I have 2t, let's say 2 plus 2t, I'm here, 2 plus 2t. Now here y will be minus 1 plus 2t, and here z will simply be 0 plus t. So we see that the coefficients of the parameters are 2 2 and 1. So simply our direction vector will be 2 2 and 1. So putting it back in our formula for sine, putting it in our formula, then I'm going to have sine theta to be equal to, our normal vector should be the normal vector was 1 minus 1 1, 1 minus 1 1, so multiplied by the direction vector that we got was 2 2 and 1, so divided by the norm of the normal vector. So if we have the norm will simply be a squared plus b squared plus c squared, all that square root. So we're going to apply this formula for the values of n and d. So if we apply this here, if we apply that here, we're going to get here we're going to get 1 squared will give us the square root of 1 squared will be 1 plus negative 1 squared will be 2 plus 1 squared will be 3, so it will be root 3. Now times the square root of 2 squared is 4 plus 2 squared will be 8 plus 1, so this will give us 2 squared is 4, so this will give us 9. So we'll be left with doing the dot product here. We're going to have 2 minus 2 plus 1 divided by so this will give us 3 root 3. So this will give us 3 root 3. So 2 minus 2 will give us 0. So this will give us 1 divided by 3 root 3. So the correct option there is option C. Now to do dot product, let's say I'm doing the dot product of A, B, and C with let me say with D, with C, with D, E, and F, with D, E, and F. Then I'm going to get let me create some space here to do the dot product. The formula that I use down here, this will simply be equal to A times D will be A times D now plus B times E plus C times F, So I apply this formula here to get this, Okay, thank you guys very much for watching my video. If the video was helpful, please subscribe and like. You can also share the video in order to support the channel.